Now let's see some types of numbers here. One is even numbers, you must be knowing about it. Set of all even numbers are divisible by 2. If any number is divisible by 2, we say that it is an even number. So 2, 4, 6, 8, so on are even numbers, right? And set of all odd numbers, the numbers which are not divisible by 2, which means if they leave a remainder of 1 when you divide with 2, then they are all set of odd numbers. Now prime numbers, no factors beside 1 and itself. So these numbers doesn't have any other factors besides 1 and itself, right? For example, if you take the number 5, you cannot have any divisor for 5, right? So only factors possible for 5 are 1 and 5. And composite numbers means these are the numbers which have other factors besides 1 and itself, which means if you take 4, 6, the numbers like this, let us say 6, it is 2 into 3, therefore other than 1 and 6 it is having factors 2 and 3, right? And one important point here is we are not going to classify 1 as either prime number or a composite number. Other than 1, we can classify all the remaining natural numbers as either prime numbers or composite numbers. And few important points you can remember here is, one thing is every composite number can be written as a can be factored into many prime numbers. So what I mean to say is, if you have a number 10, it is a composite number, it can be written as a product of many prime numbers, which means it could be written as 2 into 5. This is called as prime factorization, right? So what is prime factorization method is, every composite number can be written as product of prime numbers. Got it? Okay. And one interesting thing is here, if you try to see this, now let us say there is a number 144, or let me take a small number, now 16, if I take 16, okay, now we know that the factors of 16 are, one is I can write it as 1 into 16, that is one type, and the other is I can write it as 2 into 8, and the other one is I can write it as 4 into 4, right? Now if you see a number, let's say 16, the square root of 16 is 4, right? Now if one of the factor lies below 4, then the other factor has to will be on the other side, right? Similarly, if one factor is 2 is below 4, then the other factor will be on the other side of it, which means if you are going to write a number as a product of two numbers, then definitely one number will lie to the left of the square root, and other number will lie to the right of the square root. And here 4 and 4, since they exactly lie in between, either both the numbers exactly lie in between in case if the number is a perfect square, otherwise one number is going to lie here and other number is going to lie here. Got it? So similarly, if you want to see one more example, let's say 18. Okay, now if you try to find out the square root of 18, it is going to be 4 point something, right? Now what are the various factors you can write for 18? 18 could be written as 1 into 18, which means one number is less than 4 and other number is greater than 4. And 2 into 9, one number is less than 2 and the other number is one number is less than 4 and the other number is greater than 4, right? Or 3 into 6. Got it? So which means if you take the square root of a composite number, and if you are going to write that composite number as a product of two numbers, then definitely one of the number is going to lie on one side and other number is going to lie on the other side. And in best case, both the numbers can be equal to the square root if that number is a perfect square, like this example, right? So just remember these points. Now let's see prime numbers. So given a number, how can you find out whether it is a prime number or not? So let's take a small example. Let us take 17, right? So if you take the number 17, what could be square root of 17? It is 4 point something, isn't it? 4 point something. Now if this is not a prime number, you should be able to write it as if it is a product of two numbers, a into b, right? You should be able to write it as if it is a product of two numbers, a into b. Okay, let me write it here. Now I'm talking about the number 17. So is this part visible? Let us take this here. Now I'm talking about number 17. Now the question is to find out whether 17 is a prime number or not. Now the square root of 17 you know is 4 point something, right? So if this is a composite number, if it is not a prime number, if it is a composite number, then you should be able to find at least two numbers of form a into b in such a way that a and b both are not equal to either 1 or 17, right? And how will these two numbers be? At least one of them should lie less than 14, less than 4, right? That is what we have seen here, isn't it? Therefore from 1 you can search till 4, 1 2 3 4, and you see whether if any one of these numbers is going to divide this number or not. In case if these numbers are not going to divide this number, you need not check on the other side, isn't it? Therefore you can just check from 1 to 4, and then you can conclude there. And if you remember, you need not check all these numbers as well. I told you that there is something called as prime factorization, isn't it? Therefore, since every number can be written as a product of many prime numbers, you can just take only the prime numbers on this side and just check with that. If you see that no prime number which is less than square root of this number is going to divide this number, you can say that it is a prime number. Got it? So maybe if you want to see one more example, let's say if you want to test 145, whether this 145 is a prime number or not, right? You know that square root of 145 is 12 point something, isn't it? Now you take all the prime numbers which are less than 12, less than or equal to 12, since it is 12 point something, less than or equal to 12, and you check if any one of them divides it. Now first prime number is 2. I'll just check if it divides it or not. It doesn't divide it. Second prime number is 3. Yes, it divides it. Oh, it doesn't divide it, right? 3 doesn't divide it. Next 4, 5. Yes, 5 divides it, isn't it? Therefore we can say that this number is having a factor other than 1 and 145. Therefore it is definitely not a prime number. It is a composite number, right? So you can test whether a number is prime number or not by seeing this. Got it? In case if you don't know that exact 145 square root is 14, 12 point something, then what you could do is find out the next largest or the closest perfect square which is greater than 145. So you will find out that it is 169, isn't it? So which means the square root of it is 13. Therefore you can go from 1 to 13 and find out all the prime numbers between them, and you see whether it divides this number or not. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.